All right, you guys, here, quick help on how to do a regression equation with some data. And if I look at, this is number 15 from your textbook, and it comes on page 75. So either e-text or go grab a book from the shelf. The idea of getting a regression equation by the calculator, I have steps for that uploaded on Google+, and I can give you a copy. But if you just want to do it roughly with 2 points, we've done it in notes, so I have that in, I think, part 2 of the 1.1 notes. Check that out. And this is an additional supplement to that, so keep your eye out for resources. So this data that we have, it says 1954 and 1999. And so 1954 is the first one, and 1999 is the second to last one. So those are the data points that I need. And this particular one in 15, I think it asks just for order pairs to compute slopes. So write an equation for the women's data and another equation for men's data. I'm just going to do one of them. I'll just choose, let's do women's data. And then I'll leave you to do the male's data if you want to do that. So those 2 points I highlighted, so I'm going to circle just the female data. So I need those 2 output points for given input points. These are years. Generally, years end up being your inputs. And sorry about that, lost the screen for a second. So year input, and then whatever measure goes as your output. I'm going to go to a new screen here. Something really important to note that maybe I didn't mention in class. I'm actually pretty sure I didn't. Okay, so the key to making this all take place is knowing that 1954, if you read in the instructions, is the start. We're measuring everything since 1954. That means the year 1954 is our zero, our starting point. So when you graph, it'll start at 0, that's 1954, and any year we're going to go to, what, 1999, 45 years later. So I did a scale down below. The little tick marks are 5s. You see the 25s. Marked in there, and then you go to the next piece, which is, all right, we've got to plot these within that scale. Vertically, I need a scale as well that matches. So notice the first point, 032.3, that's the 1954 year, and then 45, 58.5, that's the 1999 year, and its inputs, again, according to the scale of 1954 being 0. Then up the scale, I might as well just do 5s again to fit in 32.3 and 58.5. So there they are, the 2 points plotted. Let me know if those look awkward. Then what we're going to do is, after those points are plotted, find an equation of a line through those 2 points. Then from there, the equation, remember, is just finding the slope and the y-intercept of that respective line. And I think we got a gimme, don't we? We got the y-intercept right there, 032.3. That's something that's tricky for a number of us, is being able to find that y-intercept, so that might be something I show a little bit later, but let's just use it for now. And the other part would be the slope, which is y2 minus y1 over x2 minus x1, if you're formula people, or change in y over change in x if you like. The concept is just how much difference between your y's and how much difference between x's. You have to subtract them in the same order, or your slope will have the wrong sign, and y is always on top. So these are definitely going to give us a positive value. 58.5 minus 32.3. Should we throw in some mental math in there? And what do we got? 26.2 on top, something like that. And then, of course, 45 on the bottom. Divide those two, we get about 0.582 repeating. That's our slope. So we go up to the top there. I'm going to throw in 0.582, roughly. Let's call that close. And there's our equation of our line. Slope of 0.582, put it in front of x, plus a y-intercept of 32.3. That's the idea of getting an equation of a line. The only other difference would be if you had to go find mathematically the y-intercept. So if it wasn't 032.3, that's when you use the point slope form. So let me just do that real fast. I'll jump to the next page if I can. Add a page. Here we go. The equation y minus, I like using the point slope form, and I think many of you found it pretty useful yourself. But this is where you plug in a point that you know and a slope that you know. Well, we've got the 0.582. And that part's good. Then what we need to use is one of our x coordinates and one of our y coordinates. I'll leave the blanks there so you can see where they're going. Remember, y1 and x1 represent the place where we're going to substitute in one of our points. Remember, if I go back, we had 0, 32.3, and 45, 58.5. It doesn't matter which one you choose. I'm going to choose the 45, 58.5. Kind of makes it more interesting. So this is 45 for x, and then 58.5 for y. That's our equation. Oops, sorry, lost my equal sign in there. that actually works for the equation. You could stop there unless somebody says you must get it into slope-intercept form, at which point you add 58.5 to both sides. So this little dude, distribute the 0.582. I'm going to do that later, let you guys kind of look at it as is, and maybe just let you have that fun yourself. And then plus 58.5. There's your equation that way. Now I'm just going to distribute here and call it good. And that's the step I'll do here. A little distribution, 0.582x minus 26.2 plus 58.5. Hey, guess what those end up adding to, those last two numbers? Want to guess? 32.3, which is the y-intercept we got before. So our equation is exactly the same if we simplify that we got doing it just by knowing the y-intercept was 0.32. If you plug in the numbers using this slope-intercept form, point-slope form, it works as well. Whoa, weird typo there. X, sorry for the sloppy X. Good grief. Plus 32 point, what was it again? 32.3? Yeah, something like that. There you are. That's the same equation. Again, when you see these, I mean, they're both equivalent equations. This is a good equation, and this is a good equation. Just depends on what your needs are later on. That's it. Hope that helps.